Welcome to the Task Marx Help Guide. Presuming you have installed Task Marx, let's go ahead and open it. You will notice I am running Task Marx as administrator. When opening Task Marx for the first time, it will ask you if you would like to enable automatic updates. I suggest you do enable them. If you don't enable it, you can always re-enable them within the application itself. To get the most out of Task Marx, I advise you run it as administrator. If you don't, it will run in limited mode. But Task Marx will prompt you if it sees you aren't running it as administrator when starting up the application. I advise you to read through the disclaimer. Before we take a look at the CPU controls, let me show you how to enable and disable automatic updates. So to do that, select the settings cog. As you can see, there is a checkbox where you can enable and disable automatic updates. You will also notice that Task Marx has a few themes which you can also change here. Let's now look at CPU details. The CPU details control shows you information on the processes installed in your system in real time. Please note this control does support multiple CPUs. You may have noticed the alternative usage stats checkbox in the top toolbar. This option, when selected, provides a different source of information for your processor's usage stats, that being total usage and thread usage. Please note, the CPU details control does support multiple CPUs. If you had multiple CPUs, each CPU would be represented with its own information panel. Please note, the panel is draggable. So, for each panel, it shows real-time information for the given CPU installed in your system. So firstly, we have the usage bar, the usage graph, the manufacturer of the processor, the number of cores and threads for the given processor, the core's base clock, or should I say the processor's base clock, the current clock, the max clock the application has witnessed for the given CPU, its level 2 cache size, level 3 cache size. Then to the right of that, we have some more real-time stats, thread usage for all the threads for the given CPU, the current core clocks, and then whichever temperatures we can access for the given CPU. Let's now move on to CPU benchmarks. Task Marx has 4 different CPU benchmarks that you can run. We firstly have the all-core benchmark, the single-core benchmark, then we have the 2 rendering benchmarks, the multi-workload benchmark and the single workload benchmark. So for the all-core benchmark, this initiates a full load across all the cores of your CPU or CPUs. Once the benchmark is finished, you will be given a score which shall appear below the start button. Please notice that each benchmark also has a set of reference scores you can compare your scores to. From time to time, we will be updating these scores and possibly in the future even have an online system where users can compare their scores with each other. To see the reference scores for each benchmark, you simply select the reference scores buttons. And then here, once selected, you'll be able to see various scores for various systems. Your score will appear in the top right. Please note that your scores will be updated onto the system when closing Task Marx, given that you've run the benchmark to the end. We then have the single core benchmark, and the same rules apply. When completing the benchmark, your score will appear below the start button, where you can then compare it to reference scores. Please note that your scores will be updated to the system every time you run them, but will only be updated when you close Task Marx. We then have the 2 rendering benchmarks, as already mentioned. So firstly, we have the multi-workload and the single workload. To run the benchmarks, you simply select which benchmark you'd like to run, and then select the start button. These benchmarks are designed to test the thread optimization and efficiency of your CPU over time. They will not initiate a full load across your cores or core of your CPUs. The reason for this is it's to test how your CPU optimizes itself over time when rendering an image over and over again, which results in the same instructions being sent to the CPU over and over again, where certain instructions are cached. That's basically how it is in short, but over time your CPU will optimize itself because it's become familiar with the instructions. Let's now move on to RAM. So, starting from the left, we have the total amount of memory installed in your system, the amount of memory currently used in your system in real time, and the amount of memory free for your system in real time. To the right of that, we have the DIMM or SO-DIMM selection. Here, you can select which module you would like to see information on for the modules of RAM installed in your system. When selecting each module, you'll see the information will change, representing the information for the selected module. We then have the RAM stress test. The RAM stress test, when started, will write values to your RAM. It will then pull the values out and evaluate them. So essentially it's doing write and read checks. What it will do is it will fill your RAM until the value here is reached. When I say the value, this is the RAM threshold. The RAM threshold being how much RAM is free on your system that it cannot fill. So by default, we set it to 384 megs. So if I had to start this test, it would write data to your memory until 384 megabytes of RAM are free on your system. From there, it will then pull the values out of RAM and evaluate them. That way, we'll be able to check whether the data was written to your RAM correctly and then read from your RAM correctly. Right, let's now move on to GPU details. So as you can see, we don't have any GPUs selected. This control supports multiple GPUs. To select a GPU, you will select the drop-down panel here. From here, you'll see all the GPUs installed in your system. Currently, we only have one, so let's select it. As you can see, we have the model name, the manufacturer, the total amount of video RAM, the device ID, the plug-and-play device ID, the status, whether the hardware is enabled or if it's faulty or not, the driver version, the driver date. Then to the right of that, we have all the real-time information we can obtain for the GPU. So we have power, so that's in wattage, GPU clocks, temperatures, loads, fan usage, fan control, that's in percentage, that's in RPM. GPU data, like the VRAM, how much is used for the various different metrics. And then GPU throughput. Along with that, you'll also notice we have this resolution and monitor area. So, in the monitor area, we have the monitor's resolution for your number one monitor. Your number one monitor being the monitor labeled as number one in your Windows display settings. To the right of that, we have the screen refresh rate tester. This tests the refresh rate for your monitor that is labeled as your main display within the Windows display settings. So to initiate the refresh rate tester, you simply just click the screen. To stop the test, you simply click it again. That brings us to the end of the GPU details control. Let's now move on to processors. So you'll currently see that the processor's control is just syncing with the operating system. What it's doing is it's obtaining all the information for the current processes running on the operating system before it displays them. As you can see, the processor's control has now finished syncing with the operating system. So let's now look at the processes that are running in the list. Firstly, we have columns representing specific values related to each process. We have the process ID, its parent ID, the name of the process, the amount of RAM the process is consuming, the amount of CPU usage the process is using, along with the net send and net receive. So those are the values for any type of internet traffic, whether it's sending or receiving data. And then we have the disk usage, which is a combined usage for read and write. You can order each column by simply selecting the header, and you can order them by descending or ascending order. You may have noticed some of these options at the top of the screen. Let me now run through each one. So firstly, we have the reorder on refresh. So what happens is every time the list is refreshed, if this checkbox is selected, it reorders the list according to the order by column you've selected. We then have the keep running information. So if that checkbox is selected and I leave this control, it will keep running in the background to maintain all the usage statistics for all the processes running. Then we have run and optimize mode. So when this is checked or selected, it only refreshes the information for the processes you can see. Then to the right of that, we have the total processes with the count. Then we also have this processes information panel. So how this works is when you select a specific process, it gives you additional information along to where the process originated from. So it's given folder location. If selecting the open location, it will actually open the folder where the process originated from. You can also kill processes by simply selecting the stop process for the selected process in the list. Let's now move on to sensors and widgets. So now that the sensors and widget control is loaded, you can see we can obtain and show all the information for each hardware device installed in your system. So firstly, we have the CPU, the GPU, the RAM, your hard drives, your network interface adapters, your motherboard, and so on and so forth. We show whatever hardware information we can obtain for data that we can represent in real time. Then we have the widget design panel. So, what is a widget? A widget is a desktop gadget or overlay which can be customized and used to show selected hardware sensor information in real time. Let me open the default widget profile that comes with Task Marx. So, as you can see, the widget is now running and is showing the current total CPU usage for the CPU installed in the system. It is also showing the total RAM usage and total amount of free RAM in real time for this system. Note you can resize the widget by using the resize control. You can also drag the widget to any location on your monitor or monitors. To close a widget, you simply select the close button. You can also send widgets to the tray by selecting the send to tray button. Let's now quickly create and edit a new profile for a new widget. So to do that, let's start by selecting the new button. So let's start by selecting the first sensor or text we'd like to be part of our new widget. So let's start with the name of the CPU. Keep in mind you can rename the sensor to whatever you want. So let's just call it Intel Core i7. Let's set the font size to 14. The color of the font, let's define a color. We'll leave the font as bold, and now we'll add it to the widget designer. As you can see, the text is now added to the designer so you can see what it will look like. Say we wanted to edit this, you simply select what you would like to edit. You'll see an arrow will appear for the selected information or selected label. From here we can then go and edit the data, or should I say edit the settings for the selected label. So we can change the color, we can change anything. Alright, let's select another sensor. Let's get the total load for this CPU. So we'll just call it usage. Change the font size to 12. Let's change the color to yellow. There's the show measurement option. So this shows the symbol for whatever the sensor is measured in. So as you can see, for total load, it's in the percentage sign. Let's now add that. Say we wanted to move a selected label. To do that, you simply select the text, and then to move it left and right, you use the X control, and to move it up and down, you use the Y control. Let's add a couple more here. and you can keep going, so on and so forth. So from here we can also change the background color of the widget. So to do that, you select the back color and then select a color here. If it's not within these basic colors, you can then define it yourself. So let's go with like a dark gray. We can also change how transparent the background is for the widget itself. So to do that, you change the opacity control by simply increasing or decreasing the value. Before we create the profile, we can test the widget. So to do that, we can simply just open it. Also keep in mind, you can open as many widgets as you want. We aren't seeing the percentage sign here, so let's quickly update that value or update that label. Let's now see what it looks like. There we go, the symbol is now there. I think I'm happy with that. So let's now give it a name. So to create the profile, we simply select the Create button, follow the prompts. Now you should see it in the list. We can select it and there it is. Now you can go back and select any profiles and edit them. So if we had to update this profile, say we wanted to change this to just core, you can. We then save, follow the prompts. Do you want to update the profile? Yes. Profile updated successfully. You can also delete profiles by simply selecting the delete button and refresh the list by selecting the refresh list button. Let's now move on to FPSS widget. FPSS stands for frames per second scene. It is a frames per second counter, but it doesn't work like a traditional FPS counter. It looks for activity on your monitor, and it is limited to the refresh rate of your monitor. The reason why we did this is we wanted an FPS control that can be used for anything. It can even be used for applications and games where the GPU actually isn't doing the rendering. There's actually just software rendering. So as long as your screen is active, it will be able to get the frame count, obviously within the limitations of the refresh rate of your monitor. So let's now open the FPSS widget. As you can see, the counter isn't really moving. This is because there is currently not much screen activity happening for the selected application. The selected application obviously being Task Marx. The widget itself has 4 different modes which can be changed and toggled by selecting these buttons. As you can see, the gaming mode can be toggled twice as there are 2 different gaming modes. These modes, that being the gaming modes, are designed for games that are being played at a high refresh rate, where there are multiple frames being rendered with a lot of pixel and screen activity. The good examples of this would be first-person shooters like Call of Duty, Doom, Quake, so on and so forth. We then have the 2 other options, that being the vertical and horizontal modes. These modes are designed for applications and games where the number of frames being rendered are a lot less. I would say any frame rate under 50 frames per second. That now brings us to the end of the guide. Thanks for watching.